Hello everyone, welcome to NG Classes YouTube channel for a video lecture series on basic electronics. In the previous video we understood the basic operation of PN junction diode. In this video we'll consider the next concept, that is biasing. So I have written the same thing, biasing. So first of all we should know what you mean by biasing. Biasing is the process of providing external supply voltage to the electronic component, to a diode, to a transistor, something like that. The biasing is the process of providing external supply to the electronic component. The next question is, why do I have to bias? Why do I have to give biasing? What could be the reason for that? The very interesting and the very easy answer is, if I want to use diode in the practical application, I should make it work. How should I make it work? I have to give the external supply. So that is why I have to make it biasing. Is that okay? So in the diode we understood that after some time when I join the p type and n type chemically, after some time the process of diffusion stops because of the force of repulsion, and now it is in a ready to use. If I want to use it in external world, I have to bias it. I have to give the external supply so that it starts working. Is that okay? So that is why I have to make it bias. And in biasing there are two types. One is forward bias. I said there are two types of biasing. One is the forward bias and second one is a reverse bias. So let me write the same thing. The second biasing, I would call it as a reverse bias. So in this video we'll consider only the forward bias. So I'll consider the forward biasing and I would see what is the process and how does this operate. For this let me consider the diode which has p type and n type. I would consider this, yes, and yes. This I would call it as p-type semiconductor, and this I would call it as n-type semiconductor, and this I would call it as a depletion region. Are you getting it? This I would call it as the region of depletion, or it is also called as simply as a junction. So this I would call it as depletion region. Yes. And now if I want to use it to the external world, I should have the leads, contact leads, so that are being provided over here. Yes, and another lead over here. Now the next question is, I said I need to bias it, so I got a battery now, and a battery has, I'll write it, a battery has two terminals. One is a positive terminal and another is a negative terminal. So the bigger lead I would call it as positive lead, and the smaller lead I would call it as a negative lead. So if I want to connect a battery to this diode, what type, positive side of the battery should be connected to where, and negative side of the battery should be connected where, that I should understand. If I want to make it forward bias, I should connect a positive terminal of the battery to p-type semiconductor. Is that okay? So that is the very basic concept. So let me draw the same thing. I have considered p-type semiconductor, and now I'm joining it to the positive terminal of the battery. So here let me draw that. So this I would call it as a positive terminal, this is negative terminal. So I will draw another pair of that. This is positive terminal, this is negative terminal. So now I take this and I connect it, the negative terminal, to n type of the diode. Yes, I would join these two things. Yes, the job is done. So now I have made this diode biased, and to be precise I would call it as forward biased. Why it is forward biased? Because p-type of the semiconductor, p-type of the diode has been connected to the positive terminal of the battery, and n-type of the diode has been connected to the negative terminal of the battery. Hence I make it as forward biased. So what happens if I make it forward biased? That also I should understand. Before I consider that, let me understand how do I get the current. If I want to get the current in a diode, the holes from p-type should cross this barrier and they should move towards the n side, and similarly the electrons in n side, they should cross this barrier and they should move towards p type of the diode, so that I get the current. So how do I get that process? So that let me try to understand that. If I see that p-type of the semiconductor has been connected to positive terminal of the battery, so what could be the force here? Is that the force of attraction or the force of repulsion? Can you getting it? So I'm asking, is there a force of attraction or the force of repulsion? The answer is the force of repulsion. Why is that? Because they are of similar type. The p type is rich of holes which are positive, and this is also connected to positive terminal of the battery. So obviously there is a force of repulsion, so they'll get repelled. And where do they have to move? They have to move towards n type only. Are you getting it? As there is a force of repulsion, they get repelled from positive terminal of the battery, and they have to cross this barrier and they have to come to n type semiconductor. Are you getting it? But we understood that there is a barrier, and it has some voltage, it has some potential, so that the process of diffusion stopped. If I want to make this diode conduct, the battery voltage must be greater than this barrier potential, so that then only the holes from p type, they move, they cross the barrier and they move towards n type material. Is that okay? So now come over here. The n-type material has been connected to the negative terminal of the battery. So what is the force here? Is that the force of attraction or there is a force of repulsion? The answer is, again, there is a force of repulsion. So let me write the same thing. There is a force of repulsion. What happens if there is a force of repulsion now? Again, these electrons, they get repelled from negative terminal of the battery, and the result is they start moving towards p type of the diode. But to cross this barrier, the only constraint is the battery voltage must be greater than this potential of the barrier. If that is greater, obviously the electrons would move from n type to p type, and holes would move from p type to n type, so that constitute the current, and I would call that as the diode current. Is that okay? So this is what happens in case of forward biasing. Under forward bias, I would say that diode conducts. So that is a very important point, and that is a very important conclusion that I made. Diode conducts. When does diode conduct? Diode conducts during forward bias. Is that okay? So if I want to write the same thing symbolically, that should also be, I should be able to make it out. The diode symbol, we know that it is represented in this way. So this I would call it as p type, and the line I would call it as negative type. So I would consider that and use it for my external world, for any application purpose. So this I would connect it to positive terminal of the battery, and the negative terminal of the battery is connected to the negative of n type of the diode. So this is positive, this is negative. So if I want to use in the circuit diagrams, I cannot use every time p type, n type and barrier. I don't use it. I use this symbol. Symbolically, this is how it appears. Is that okay? So this is what happens in forward bias. In quick, if I want to revise, in case of forward bias, I connect positive terminal of the battery to p type of the diode, and negative terminal of the battery to n type of the diode. As soon as I connect, there is a force of repulsion, and holes get repelled from positive terminal of the battery. They get attracted towards n type material. Similarly, n type material, this is connected to the negative terminal of the battery, and the electrons over here, they get repelled from the negative terminal of the battery, and they get attracted towards the p-type material. As they both electrons and holes cross the barrier and they move in either of the in each of the junctions, and I get the current that I call it as the diode current, and I would say that the diode conducts. And if I want to represent the same symbolically, I use the symbol of the diode and I connect that p type to the positive and n type to the negative. This is how I represent the symbolically. I hope everyone has understood what happens in forward bias. And if there are any doubts, please let me know them onto the comment section, and I would definitely address those doubts. Meanwhile, subscribe to our channel NG Classes for more videos on basic electronics. Thank you everyone for watching.